the acceleration constraint in terms of components, for example, right? A1, the x equals A2 to the y. If that's the appropriate answer.
So that just means like the acceleration of block 1 in the x direction would be this. That's all it's saying.
Okay.
So acceleration constraints. With Newton's third law, we find action-reaction pairs, right?
Yeah.
So we can say like FB on A will be equal to FA on B. Usually when we're solving problems, it doesn't give us quite enough information. Even though those two are equal to each other, we'll usually have an extra unknown in there. So acceleration constraints allow us to know that acceleration is the same and to have that third unknown kind of fall out. It just gives us another equation. So basically, this one, you got a force of a push, block 1, block 2. So what will be the acceleration of 1 compared to acceleration of 2? Which ones will be equal to each other?
Block 1 and 2 equal.
Yeah, so the acceleration of 1 in the x direction will be equal to the acceleration of 2 in the x direction. Because they're moving together, they're going to accelerate at the same rate. So that's an acceleration constraint. It's as easy as that.
Okay. So this one, for a pulley system, would be block A. Moving in the x direction is greater than block 2.
Let's look at it.
No, block 2 would be greater.
So they're tied together with a rope. It's fallen. So since they're tied together with a rope, you assume that the rope isn't stretching out or anything. So if block 2 is moving with a certain acceleration, what does that mean about the rope?
It's going to be all the same.
Right, so what about block 1?
That'll be equal.
Yeah. So you could say that A1 in which direction?
At x.
It's going to be equal to
A2. And the y.
And if you look at it, if you put your coordinate systems like this is positive x and this is positive y, this is a positive acceleration, right? What about this acceleration?
It's a negative.
Yeah, you just want to throw that negative sign in there.
So which one would be like different? Like which one would be not equal to? They're all equal.
So this would be negative A1x would be equal to A2x. And this one, it just goes over. But when you go into this last one, it's a little bit different.
16.
Yeah. So you've got a pulley down here. This goes up to a fixed place. And then block 2 is hanging from the pulley. So will they move at the same rate now?
Oh.
So what you can do here is you kind of like say, well, what's this point? So this length here and then, so you could call this like the position of A. And this length here, or position 1. S1 and S2. So if you take the length of the rope, ignoring these little parts that don't change, so like the stuff around the pulley, and so this length is always going to be the same, this length will always be the same, this length will always be the same. But this length will get shorter and this one will get longer, right? So what are your So you got S1 plus 2S2 equals the length of the rope. And if you took that derivative twice to get the acceleration, you'd have the acceleration of 1 plus 2 acceleration of 2 equals 0. You know, I'm not sure, I can't remember how the book shows you how to do these kinds of problems. But basically you look at it and you say, well, 1 is moving and it's just got the one rope. But this one has both ropes, so it accelerates down. But whatever length you take out of this rope goes into both of these ropes, right?
Right.
So you divide it by 2. You take the length here and you take it and stick it on 2 ropes.
Okay.
And that's what you see. You have A1 is going to be equal to 2A2. So that means that A2 is 1/2 of A1. That makes sense? So this block will move down. So like when you slide this block over, it's gonna lower block 2. Block 2 will only go half as fast, right? Since you take this distance and you divide it among 2 ropes, it'll only go half as fast.
Gotcha.
So then if this went up around like another pulley, and then back to this pulley, and you take this rope, you take this length and you divide it among 3 ropes. So how much, like, what would be the ratio here?
1/3.
Yeah. And that's about as complex as problems get in this class. As long as you just have one rope, then you can basically just count how many are going to the pulley or going to that object.
But it could be A1 equal to A2 or 1/2.
So, yeah, you can do it either way. You can say A1 equals 2A2, and then you watch your signs. So this is going to be positive X and positive Y.
The negative 20.
Yeah, so A1 will be positive and A2 will be negative.
Okay. A1 X equals negative 2A.
Yeah, negative 2A2. Y.